Okay, so if you've ever been roller skating or maybe ice skating, you've seen this or you've done it where you have two people and they back up, their friends, and they like skate towards each other, and they kind of go right at each other, but at the very last minute they go to the side and then they grab each other's hands and they go like. Okay, so this is one of those scenarios. Okay, so we have these two identical twins. They're going to go racing towards each other. Okay, and they're going to grasp hands. They're going to spin around. Now, what I'd like to know is how much force are they going to have in order to pull this off? Okay, so based on the numbers I've just sort of thrown in here, is this even remotely possible? Okay, so we'll get some idea. And, okay, so we start with our sketch. So we've got our two girls, and they have a mass of 40 kilograms each. And they're accelerating 2.5 meters per second squared toward each other. Okay, and they start out a distance apart of 50 meters. Okay, then once they get close together, they offset just a little bit. And they end up spinning around each other like this, holding each other's hands. Okay. And our distance here is 1.5 meters. So in terms of like a spinning radius, that's 0.75 meters. Okay. Just like that. All right. So let's begin with, we got our sketch done. Let's do our free body diagram here. And I'm just going to focus on one of the twins. It'll be equal and opposite for the other one. All right, but there's got to be some kind of force in here like this. And we know that the acceleration is going to be toward the center, just like that. Okay, so start with Newton's laws here. And we've got force down, it's M, and the centripetal acceleration is down. So we've got this right here. So if we knew the centripetal acceleration, boom, we could get the force piece of cake. So we're looking at mv squared over r. Okay. I don't know omega. But I'm going to have to do some kinematic stuff to get something about the speed. So I thought, well, we'll just leave it like this and see how that goes. Okay. So now let's work out what the velocity is. Okay. So we know acceleration. We know a distance. This is a perfect opportunity for Bumblebee. So, whoa, what the heck is that? Here we go. It's a perfect opportunity for Bumblebee. V final squared. V initial squared plus 2a delta x. Okay. All right. So I got starting from 0, 2, onto 2.5 meters per second squared, onto 25 meters. Okay. That's what we've got there. Now, when you work all that out, V final squared, we get 125. And then the units on that are going to be meters squared per second squared. Now, V squared is nice because I've got V squared up here. I don't actually have to know the velocity. I mean, I was curious, and so I went ahead and took the square root. And what you get is 11.18. Meters per second. And so they are flying. Okay. Woof. When they get next to each other. Okay. So let's go ahead and run the numbers now. So F is mass, which is 40 kilograms. And then our V squared is 125 meters squared, second squared, over meters, which they're 0.75 meters apart. Now, when you punch that in on your calculator, what you're going to get is 6,670 newtons. Okay. Now, it might be kind of like, oh, all right, so it's kind of a big number. Is it a lot or not? Okay, so let's compare that number to the weight of the twins. Okay, now the weight of the twins is simply going to be mg. So we're looking at 40 kilograms, 1.81 meters per second squared. Okay, and so that weight is 392 newtons. Okay, 300, so just under 400 newtons. And they're at 6670. So if you divide and find out what's the ratio of the force they have to hold to their body weight, you get like 17. Which means this scenario is not realistic at all. I mean, they might go, maybe they could get up to that speed that we got there, 11.18 meters per second. But when they try to grab each other, there is no way they're going to be able to hold on. No way at all. And even if they did, they would really regret it. They might pull their shoulders out of sockets or something. It would be bad. Anyway, there we go.